Hi guys, in this lecture video, I'll be discussing the nuclear symbol. So what is a nuclear symbol? A nuclear symbol is basically a way to represent the composition of any particular atom. Now we see that different atoms have different number of proton, neutron, and electron to them. And that is something that we need to keep track of. And by using or writing the nuclear symbol, it allows us to figure out how many proton, neutron, and electron that any given atom would have. And before we get going, it's important that we remember some of this property right here. First, it is the number of proton, or also called the atomic number. And this number is abbreviated with the number Z that define the element. So again, the number of proton that define the element. Different element will have different number of proton to them. And we can see that different element can have similar number of neutron and electron, but never the proton. Because if two atoms were to have the same number of proton, they would be the same element already. So therefore, the number of proton is unique for every substance, for every different types of atom. So now let's go over how do we write the nuclear symbol of a neutral atom. So we have a neutral atom, how do we do it? And the nuclear symbol consists of the following. First, it may consist of a one or two letter that represent the symbol of the element. So this E right here is the element symbol. And to the left side, on the lower corner of the element symbol, this is where we will be putting the number Z, or the atomic number. Atomic number, and this is the number Z. And this atomic number right here is basically the number of proton that the atom would have. And that way it would go. And on the top left corner of the element symbol, this is where we'll put the atomic mass. And the atomic mass is abbreviated with this number A. So A here, this is the atomic mass. The atomic mass is also referred to as the mass number. Now, please remember that this is different than the atomic number. So the atomic mass, or the mass number, is distinctly different than the atomic number. And the atomic mass is basically the sum of the number of proton plus the number of neutron add together. And that go into this upper left corner of the element symbol. So how do we then count how many subatomic particles that any element have? So let's now learn how to identify the Z and the A number, as well as the number of electrons as well. So first, when identifying the element, always pay attention to the number of proton, or the atomic number, because this is specific for every different element. And second, the atom get its mass, or the atomic mass, or its mass number, from the mass of the proton and the neutron add together. So once we are aware of this, if we were to know one of this piece of information, we should be able to figure out the other value. So here is the equation. The atomic mass and that is the number A, is then equal to the number of proton. And this is the number Z plus the number of neutron. And this is the number N. So that's the equation right here. So if we were to first know the element, that tells us we know the number of proton already. And we also know the atomic mass as well, because that's something that we can look up on the periodic table. That will then allow us to figure out how many neutrons that the atom would have. So that's how we can figure out and solve for the number of neutrons. So neutron N will then equal to A minus Z. And lastly, let's now determine the number of electrons. If we were to have a neutral atom, that tells us the number of protons must equal to the number of electrons. So therefore, that's how we can figure out the number of electrons that an atom would have. So the number of electrons would equal to the number of protons of the atom have. So if we know what element it is, and we know the fact that the atoms is neutral, then we can easily figure out the number of electrons that the atom would have. For an example, here is the nuclear symbol of aluminum, and aluminum has the atomic number of 13 and the atomic mass of 27, and that's where those information would go. And when we count proton, electron, and neutron, we will then see that aluminum will have 13 protons, and because this is a neutral atom, therefore the number of protons must equal to the number of electrons. So therefore it should also have 13 electrons as well. And here in this case right here, because the atomic mass is equal to 27, and now we see that that is the sum of the proton and the neutron add together. So in this case right here, to figure out the number of neutrons, we simply take the atomic mass minus the number of protons, and then that would then give us 14 neutrons. So that's how we can figure out the number of subatomic particles of any element. Let's now try a few examples. So in this case right here, given O and 8 and 6 here, first, what would be the name of this element? And by now, you should know that the symbol O corresponds to the oxygen. So that will be the name of the element. And now, as for proton, electron, and neutron, oxygen has the atomic number 8, so therefore have 8 protons to it. And because this is neutral, so that tells us it should also have 8 electrons. And because in this case right here, the atomic mass is 16. By taking this 16 minus this 8, that tells us how many neutrons that oxygen would have. So in this case, also 8 neutrons as well. Okay. And now let's now do an example. Given the element carbon, what would be the nuclear symbol for it? So the symbol of carbon is C, and now carbon has the atomic number equal to 6. And as for the atomic mass, it equal to 12. So on this atomic mass right here, make sure you round this to the 1. So round that to a whole number. On the periodic table, it should say 12.001. And in this case right here, we'll be round this to 12. And we'll go over why we need to round that to the first place in a little bit. So that will be the nuclear symbol of carbon. And now when identifying the number of proton, electron, and neutron, carbon have 6 protons. And because it's neutral, so that means it also have 6 electrons as well. And finally, when we take the number 12 minus the number of protons, which is 6, this gives us 6 neutrons. So it's quite easy for us to determine how many proton, neutron, and electron any atom would have. Let's now try another example. Given this following information, identify what element this will be. So in this case right here, we are given or being told that an element have 78 proton, 78 electron, and 117 neutron. So what element must this be? Then again, to identify the element, we need to be looking at the number of proton. And this number right here is the atomic number. And now, by referring to the periodic table and go to the element number 78, we will then see this would correspond to platinum. And the nuclear symbol platinum consists of PT. It is 2 letters. And on the lower left corner, we will put 78 right here. And in this case right here, we need to figure out the mass of this platinum atom. And we know that the mass is the sum of the proton and the neutron add together. So by taking 78 and plus 117, this equal to 195. And that is the mass number of platinum, or the atomic mass of platinum. And now, we can also apply the same analogy and write in the nucleic symbol of an ion as well. So what is an ion? An ion is basically when an atom gain or lose electron. Then if they were to gain or lose electron, the species that they now become is something that we call an ion. And they carry a net charge on them because electrons have negative charge to them. So if an atom were to be neutral at the beginning, and now it is gaining or losing electron, it will then become charged at the consequent. So the number of protons and the number of neutrons do not change when an atom forms ion. So therefore the mass of the atom then remains essentially unchanged as it forms ion. So only the charge is changing, but not the mass of the atom, because losing or gaining an electron do not really affect the mass in any way. If an atom were to gain an electron will then cause the atom to become negative charge. And negative charge ions are also called anion. Versus if an atom were to lose electron, it would then become positively charged because you're losing something that is negative. It would then become called the cation. And we see the following. Metal tend to form cation because that is the definition of metal. They like to give up electron. So that's why they form cation. While non-metal tend to form anion because they like to accept electron. So therefore they become negatively charged. So let's say here we have E, which is a neutral atom. If this atom right here were to gain electron, and gain electron, this would be the property of the non-metal. Then now it will become the following. It will become negative. So this is the negative ion. And we also call this the anion. Versus if the atom were to lose electron, and this will be the property of the metal. Metal like to lose or give up electron. And because now we have a neutral atom and it loses an electron, it will then become positively charged. And this is where we will put the positive charge. So this becomes a positive ion. A positive ion is also referred to as a cation. So rather than say positive ion, we can simply use the word cation to represent to it. And again, here is the full format to represent the nuclear symbol of an ion. We have to add its charge to it. So its nuclear symbol look as follow: E, and now the Z is still go here, the A is still go here. And as for the charge of the element, we put this on the upper right corner of the element symbol. So whatever is the charge, whether plus or negative, this is where we will put it. So this is the net charge of the ion. And this net charge right here, it basically can be figured out by taking the atomic number and minus the number of electrons. That the atom now have, and that allows us to figure out what is the charge of the ion. And when we name an ion, be sure to specify its charge as well, so that way we can distinguish it from the neutral atom. For an example, here are some of the nuclear symbol right here of magnesium. So here we see magnesium, and in this case right here, we don't see a charge listed on it. If we were to not see the charge listed, the atom would then assume to be neutral. So to name this, we simply call this magnesium. Versus this one right here, this is the magnesium ion, and in this case right here, it has the +1 charge. So to name this, we would then name this as magnesium +1 ion. We can use cations or simply this ion. Because when we use the word ion here, and the fact that this is positive, it already implies that this is the cation. So we can write magnesium plus 1 ion or magnesium plus 1 cation. Either way would work. And similarly, the name of this ion right here would then be magnesium plus 2 ion or cation. And now let's count the number of subatomic particles that each of these ions would have. So starting from the neutral magnesium, it have 12 protons. And because this is neutral, so that means it must have 12 electrons. And because the atomic mass here is equal to 24, 24 minus 12, this gives us 12 neutrons. So that would be the number of subatomic particles that magnesium would have. Moving on to the magnesium plus 1 ion. In this case right here, it still have 12 protons because this is still magnesium. But now here in this case right here, it is becoming plus 1, meaning it have lost an electron already. So here in this case right here, we would then see that it has only 11 electrons remaining. So they have lost an electron already. So in this case, 11 electrons. And as for the number of neutrons, then again the same thing, 12 neutrons. Because when an atom forms ions, its number of neutrons must remain the same. And moving on to this last example, magnesium plus 2 ion will have 12 protons. And in this case right here, because they form in plus 2, that tells us they must have lost 2 electrons already. So in this case, they have only 10 electrons remaining. And lastly, they still have not changed its number of neutrons. So 12, still 12 neutrons remaining. So that's how we can also identify the subatomic particle and write in the nuclear symbol of cations and anion. So please try this following example.